After studying this module, you shall be able to know how CCTV cameras work, classification of CCTV cameras, learn about the video analysis and forensics. Closed circuit television or CCTV is a device used in home and business security systems for electronic surveillance. CCTV cameras can help keep an eye on many different parts of a property at the same time, and they can also help a record of activities or incidents. Nowadays, whenever there is an incident, whether it is an accident or a theft, police always ask or search for CCTV footage for any nearby source that may have recorded the incident in full or in part. CCTV footage is one of the sources of forensic intelligence. It provides mental picture of the event for reconstruction. It can be used for crime scene investigation, provides circumstantial evidence like clothing, bags, weapons, etc. It can track the movement of the suspect or victim both prior to and after the event, trace identifiable items such as vehicle registration plates, etc. Before going for the use of CCTV footage as forensic evidence, we must understand the basics of the CCTV camera and recording system. First, categories of CCTV cameras. Indoor versus outdoor cameras. Indoor and outdoor cameras are essentially the same in terms of style, size and shape. The principal difference is that outdoor cameras contain some form of weatherproof housing or case. Next is night vision and day-night cameras. There are two camera technology solutions in low light situation. In total darkness, the only way left is infrared technology, which is known as night vision. Now we will discuss about the various types of CCTV cameras. First is dome camera. Dome cameras are a suitable choice because of their versatile dome shape. They can be placed easily on most walls and surfaces, and their round design has made it the most fashionable of all security camera styles. Most dome cameras have 3 axes, hence they can be easily adjusted once mounted. Outdoor dome cameras are available in HD and multi-megapixel resolution, which offer day and night functionality with integrated IR illumination. Some models also feature two-way audio and integrated memory card storage. Now, what are the various features of dome camera? Dome cameras can be installed easily. Usually 2 screws are sufficient. As dome cameras have an enclosed lens, the direction the camera is pointing to is hidden. Domes can provide infrared for night vision. Now second is box camera. A fixed or a box camera is the most common choice for video surveillance, as they feature an industry standard C or CS mount, which allows them to use a variety of lenses. This makes these cameras a fit choice for any video surveillance in commercial indoor environments. Enclosed in a weatherproof housing, they are frequently used for outdoors too. Third is infrared cameras. The distances that infrared cameras have the capacity to see is based upon its illumination. These cameras have LEDs which take out into the darkness. Realistically, a good rule of thumb is 1 foot for each LED. Therefore, if a camera has 30 LEDs, then it probably can see about 30 feet. Then fourth is bullet cameras. Bullet cameras are small. The category of internal boards and lenses limited. Accordingly, the image excellence of the bullet camera will not be compared with other outdated cameras, which have double layer boards and camera function controls. These features of outdoor bullet IR cameras are in analog format. They are the cost effective and weatherproof with self-contained LEDs that turn on at night, illuminating the field of view for the camera. They are robust and self-contained all in one, an outdoor bullet IR camera is contained in a weatherproof case and has built-in infrared LEDs and lenses. Fifth is wireless cameras. These are very popular cameras which do not need wires to connect the camera with the receiver and can be installed and moved from one location to the other easily. Without the wire, we can save on installation by not worrying about lengthy or complex wire runs. Also, wireless cameras give us the ability to incorporate video surveillance in discrete areas where other security cameras would be difficult to place. Since wireless is just for the video signal, we need to power the camera locally. For the most part, wireless cameras require a line of sight to function properly. The distance will differ depending upon its strength, that is transmitter and receiver. There are external wireless transmitters and receivers that can attach to any standard camera and make them wireless, but the costs are exceptionally high. Then sixth is pan, tilt, zoom cameras, also known as PTZ cameras. Pan, tilt, zoom cameras cost anywhere between 5 to 10 times the cost of a fixed camera. The pan, tilt, zoom camera will not cover or look. We cannot pan, tilt or zoom after it has been recorded. This can only be done with a 360-degree camera. These cameras can execute many functions which is not possible with a fixed camera. We can regulate it and also zoom in optically up to 52x and after digitally up to 12x, giving zoom abilities. The PTZs have intelligence and can be programmed to perform predefined tours, and upon the event of an alarm, the camera can swing to a specified location before continuing its tour. An operator can dominate and take control of the camera at any time. These have built-in auto tracking features which make the camera automatically track any movement, and it does so by panning, tilting and zooming in on the subject. Then seventh, hidden cameras. They are also known as covert or spy cameras. These are security cameras which can be used for discrete video surveillance anywhere, either indoor or outdoor or as per the type and model used. These devices can be made in the guise of common household items such as smoke detectors, clocks, sunglasses and baseball caps. Household items are rarely suspected of housing a video recording device. Business houses also sometimes use hidden cameras to keep an eye on the employees or the customers. Now we will discuss about the video quality. The producers of the CCDs mainly form 2 or 3 basic grades of products in terms of camera lines of resolution. There is a standard resolution for color cameras that are quoted as anywhere between 330 TV lines to 380 TV lines. A high resolution for color cameras which are quoted as anywhere between 450 TV lines to 480 TV lines. And a new standard some refer to as high definition, which is not true high definition, that quotes of anywhere between 520 TV lines to 550 TV lines. The more the lines of resolution in the picture, the higher the excellence of the image. Today's cameras, high definition cameras or digital IP camera, which is 720 or 1080 rows of pixel, format is 16:9, works best with wide screens. Then next is megapixel or digital IP camera. It is 720 or 1080 rows of pixels, format is 4:3. It allows to zoom into small details while maintaining image integrity. Then is standard definition or SD analog camera, which is 704 into 576 PAL, 704 into 408 NTSC and 4 CIF, sufficient to meet many surveillance applications. Then frames or images per second. Manufacturers use different expressions when identifying the speed capabilities of their products. it will become increasingly apparent why this is misleading. 30 frames per second is real time, real motion. Video is the NTSC video standard. 25 frames per second is real time, real motion video in the PAL international standard used in India. This should not be confused with fields per second, also abbreviated as FPS. Unfortunately, 2 fields equal 1 frame. So when a product states 30 FPS in its text, it is referring to fields or frames. Is it referring to each channel of the video or the total capability of the system? Is it referring to the system limitation or the operating capability? Next is lens selection. Iris. The iris or the aperture on the lens determines how the camera will adjust to light. It comes in various varieties. Auto iris, it has the capability to adjust spontaneously according to the lighting conditions. Then is manual iris, is the one that you can adjust, but as it states it is manual. Then is fixed iris, means just that it is fixed and cannot be adjusted. Then we will talk about surveillance technology. There are 4 types of surveillance technology to be considered. First is analog and time-lapse VCR based systems. Time-lapse VCRs used for CCTV are different from the domestic machines, as firstly, CCTV VCR is an industrial machine which is formed to a standard that will allow it to run 24 hours a day. Secondly, VCR used in CCTV systems are typically time-lapse machines that have the function of stepping down or up the speed of the recording tape at slow rates. When using a VCR in CCTV time-lapse system, it is important to realize that not all of the frames from the camera are being recorded. For example, VCR in 24-hour mode, only 1 image in 8 images from the camera is recorded on the tape. The recording has a short interval between each recorded image of around 1/3 second, and this forms the jerky move type images on playback. 24-hour machines, CCTV VCR, are not famous in respect of DVR because of their preservation, that the tapes are required to be altered once in a day. The only way we can view more than one camera on TV in a split screen mode is by using multiplexer that will receive all the pictures from the cameras and split it on the monitor signal. Benefits and advantages. System is very cost effective and easy to maintain. It does not need any special functions. Now the limitations: low video excellence in respect to the digital systems. Highly preserved tape should be changed every day. The VCR CCTV system does not have the ability for remote networking or remote viewing. Next is PC based DVR. PC based DVR is a DVR card built inside a computer. Inside we have motherboard, network card, VGA card, CPU, hard drive and memory, and inside is a PCI DVR card. This capture board have 4, 8, 16 video inputs. There is a conversion of the analog signal to digital signal and then further compression into MP4 when it is received at PC based system. Then it stores the data on the hard drive for archiving and playback. The DVR software offers all the essential video and recording features. For example, video compression, changing the video to a file, camera controls and display, record and playback functions. It offers good quality video recording over time gap and are easier to use and more flexible than standalone DVRs. These units are available as kits which can be installed on a PC or as complete factory built recorders and provides with all the functionality needed for a surveillance system. Some models can be extended as the needs grow, which is not possible with time lapse or standalone. DVRs. PC based DVR available in 4-channel DVR up to 4 CCTV camera, 8-channel DVR up to 8 CCTV camera, 16-channel DVR up to 16 CCTV camera, 32-channel DVR up to 32 CCTV camera. Next is standalone surveillance DVR system. Standalone DVR system is a perfect DVR solution. All function on DVR are dependent on push button or through the IR remote. Standalone DVR has off-site viewing function that allows to view from anywhere in the world. With 2 or more internal hard drives and 2 external hard drive connections, recording time can be extended later in a standalone DVR. Standalone DVR are computer-based machines which run on Linux, Unix or other proprietary operating systems that were designed to run on one application only, which makes the standalone device a reliable appliance and does one thing only. Benefits: high resolution recordings or better, easy to operate, very stable and very low maintenance, stores large amount of video or recording days, easy network integration. Limitations: the system runs on a proprietary operating system which make it not flexible to standard changes or upgrades. Next is IP network camera. Network IP camera, often referred to as IP surveillance, used for specific applications within security surveillance, remote monitoring and security camera, is a system which gives users the ability to monitor and record video over an IP network. Unlike analog video systems, network IP camera uses the network rather than dedicated point-to-point cabling. The term network video refers to both the video and audio sources that are available throughout the system. In cable, a network IP camera digitized video streams are transferred to any location in the world via an IP network, enabling IP video monitoring and recording from anywhere. Now, how do we retrieve evidence from CCTV system? There are certain guidelines for retrieving digital CCTV evidence. A documented chain of custody must be maintained for all digital CCTV evidence. Details related to the retrieval should be recorded, including A. the time, date and location of data retrieval, B. the name of the operator producing the original saved record, C. details of the recorder should be recorded, including make and model, and D. anytime errors. System displayed time versus actual current time. Other information to record may also include E. serial number of the DVR device, F. software name and version numbers, G. number of cameras connected versus number being recorded, H. a diagram and or photographs, I. the layout and location of all cameras recording to the storage device, J. identifying the cameras responsible for the retrieved CCTV data, K. identification and recording of output file format options and recording of the option chosen, L. any usernames and passwords required to gain access to the digital CCTV, M. for remote access systems, network information such as IP addresses should be considered. N. data overwrite. The current recording may need to be stopped to prevent overwriting of the relevant digital CCTV evidence before it has been recorded from the CCTV system. O. players viewing software may also need to be copied from the system. Next is visual verification. Verify that the digital CCTV evidence captured as the original record is playable and is a fair representation of what was on the CCTV system. If there is any visible loss in quality from what was viewed on the system, it is likely that a compressed format has been obtained and it may be necessary to obtain the higher quality digital CCTV evidence. Where practical, the native format should be obtained. However, other versions may also be exported from the DVR or CCTV system and may be suitable for use depending on the intended use of the data or the type of analysis required. Storage of original copies. The original copy of the digital CCTV evidence must be made at the first opportunity before any further processing or analysis is undertaken. The original copy must be stored securely with written protection. For example, warm media or an appropriately protected and backed up mass storage system should be stored as per the Australian Guidelines for Digital Imaging Processes 2012. Then processing definition. Processing is any process applied to the digital CCTV evidence where the result is primarily visual in nature and does not require further interpretation or reporting. General principles. All processes undertaken must be valid, reliable and repeatable. Acceptable processes will vary depending on the content of the CCTV evidences. Records should be kept detailing the process undertaken. Now the guidelines. Right protection of the original copy of the digital CCTV evidence must be considered before making a working copy. Warm media, CD or DVD is suitable for an original copy. Secure server storage where access and write privileges are enabled to prevent modification of the original copy is also suitable for storage. Write blockers should be considered where digital CCTV evidence is stored on USB or flash based media. All processing should be completed on a working copy. The original copy should remain secure and unedited, not modified. Notes of all processes and process settings should be recorded to ensure the process is repeatable. It is a good practice to work on the native files or files of the highest resolution. If lower resolution files are used, it should be clearly stated at the beginning of any output that high resolution digital CCTV evidence is available. Suitable processes to carry out on digital CCTV evidence may include but not be limited to transcoding, which is compression and format conversion, brightness, contrast, gamma, etc., cropping, that is resizing, speed adjustments, sharpening or deblurring, video stabilization, frame averaging. Now we will talk about video analysis and forensics. Video analysis is the new DNA for law enforcement. It is the next generation of investigation. Principles of forensic video analysis. To assist in an investigation, forensic experts can repair, recover, enhance and analyze video recordings using an array of scientific tools and techniques. Video analysis tools can be used for previewing surveillance videos or as an advanced tool for enhancing low quality videos, analyzing the events in videos and documenting analysis results. Now some facts about video forgery. With the video editing technology currently available, professionals can easily remove an object from a video sequence, insert an object from a different video source, or even insert an object created by computer graphics software. However, as these techniques become increasingly available to the general public, malicious tampering with video recordings is emerging as a serious challenge. Although tampering with video is relatively hard, in recent years we have begun to encounter video forgeries. Then features of video analysis tools. The features that are expected from a video analysis tool include the following. Project management. Each case has to be handled as a separate project, helping to organize each requirement separately. video formats and codecs. The software should contain a built-in support for large amount of different video formats and codecs with extended support through the Microsoft Direct Show framework. If some videos are only playable with proprietary players, the tool should be able to import such videos using screen recording. Next is video processing filters. The tool should be able of doing operations like blocking, artifact removal, de-interlacing, histogram enhancement, noise removal, resizing, sharpening, etc. with various processing filters. Still image editor, functions such as arrows, shapes, text, etc. can be added to the images, or effects such as blurring, pixelation or spotlighting can be applied. Documentation of analysis results. The most interesting frames of case videos can be bookmarked and annotated to better understanding of the events of interest. Other options such as scripturing, interface, video editing, meta, data viewing, hash calculation, etc. should be included. The tool should be able to analyze the video and show us the media information as above, so that it may be compared for the whole footage. Now in this unit, we will talk about comparing of the hash values. Hash value can be used to verify that a video file has not changed since the previous calculation of the hash. It should be able to calculate the hash for a given video file and compare it with the next video file. The result must be able to tell us if the values match or not. We will end this module with the summary. First, CCTV cameras help to monitor many different parts of a property at the same time, and they are also used to keep a record of activities or incidents. Cameras are well fitted with heaters as well as blowers to respond the environment and other elements that can be placed in outdoor enclosure. The infrared part of the spectrum has several technological uses comprising target acquisition and following by the military remote temperature detecting short range wireless communication, and for our purposes night vision. Processing in any method applied to the digital CCTV evidence in which the result is chiefly graphic in nature and do not need further interpretation or reporting.